Look around you and you will see thousands of different materials: paper, plastic, wood, glass, and many more. All these different materials are made up of tiny building blocks known as atoms. In this video, we're going to take a closer look inside an atom and discover what an atom actually is. So, let's begin. Atoms are so small that they cannot be seen by even the most powerful optical microscope. To see atoms, scientists must use a special type of microscope that is known as a scanning tunneling microscope. Scientists once thought that atoms were hard and unbreakable, but as the technology to analyse atoms developed, they now know that atoms are actually made up of even smaller particles known as subatomic particles. These subatomic particles include a positively charged protons, negatively charged electrons, which are much smaller than protons, and then neutrons, which actually don't have any charge associated with them at all. Different atoms contain different amounts of each of these subatomic particles. So let's take a look about where these protons, electrons, and neutrons can be found inside of an atom. Here is a 2D representation of what an atom looks like. It is important to take note that atoms aren't 2D objects, they are actually 3-dimensional objects. But when we're learning about them, it is easier to picture them on a 2-dimensional diagram to begin with. The cluster that you can see here in the middle is known as the nucleus. It is made up of two different subatomic particles. It is made up of a series of positively charged protons, and it's also made up of a series of neutrally charged neutrons. Neutrally charged means it has no associated charge with it. As you can see in the diagram, there's these little rings that surround the nucleus. These are known as electron clouds. They contain the microscopic electrons that are inside of the atom. These negatively charged electrons are never stationary. They're constantly moving around within the shells. When we think about the actual size of these protons, neutrons, and electrons, the protons and neutrons are actually very similar in size. However, the electron over here is much, much smaller. In fact, the electron is about 1,800 times smaller than these protons and neutrons. What helps keep these electrons within these shells is that negative charge associated with them. Because the protons in the nucleus here have got a positive charge, the electrons become attracted to this charge. This attraction helps keep these electrons in the clouds that surround the nucleus. In terms of the number of protons, neutrons, and electrons there are, this changes depending what atom that we're talking about. However, atoms do like to be stable. That is to say that the total number of positively charged protons like to be balanced with the total number of negatively charged electrons. This means that the total number of protons an atom has will be equal to the total number of electrons an atom has. As a result, the overall combined charge of the atom is considered to be neutral. This is because all the positive charge that protons have are cancelled out by all the negative charge that the electrons have. So the atom is considered to have no overall charge. So let's summarise. An atom consists of 3 subatomic particles. Those particles are protons, neutrons, and electrons. The protons and neutrons form the nucleus that can be found in the centre of the atom. The electrons are in the electron shells, or the clouds here, that surround the atom. The electrons are constantly moving. The size of the protons and the neutrons are fairly similar. However, the electrons are much, much, much smaller. They're about 1,800 times smaller than the protons and the neutrons. The protons that can be found in the nucleus here have a positive charge. The electrons that are found in the shells around it have a negative charge. Overall, these atoms like to remain balanced, so the number of protons usually equal the number of electrons. It is the difference between the proton's positive charge and the electron's negative charge that allows it to be attracted to the nucleus. This attraction keeps it within the shells. To finish, I'll leave you with this. Remember how I said electrons form shell clouds around the nucleus, even though each electron is approximately 1800 times smaller than a proton. The clouds that form are actually around 100 times bigger or even 1,000 times bigger than the nucleus. So let's consider this. If the nucleus was the size of a golf ball, I know it isn't, but let's consider if the nucleus was. The electrons, even though the nucleus is the size of a golf ball, would still be microscopic in size. But the clouds that form around that nucleus would actually be the size of a football stadium. Just think about it. How much space there would be. That means the majority of each atom is actually just empty space. It's fascinating, isn't it?